So just so you're aware, this is the last section of chapter 4. And we have a test on Friday. I am really hoping that this test can be a grade raiser for you. It's a normal test. Tests are more than quizzes. Okay. So a similarity transformation is either just a dilation or a composition of a rigid transformation. Remember, that could be a reflection, translation, or rotation. And then if we compose it with a dilation, now we have a similarity transformation. Okay. When we talk about similar figures, we have angles that are congruent and sides that are proportional. Okay, I want you to draw these two triangles for me, please. Are they congruent? Oh, but you said something about something. Did I say congruent? What are they? They're similar. Okay, and let's talk about why they're similar. Okay, Sam, why are you saying that they're similar? Harvey?
Because the sides on them are either multiplied by 2 or divided by 2.
Okay, our sides are proportional. If we take and divided by 5, what do we get? Okay. If we take
The scale is 2.
8 divided by 4, we get 2. If we take 6 divided by 3, we get 2. Since these are the same, okay, that would be our scale factor, right? Our sides are proportional. We would write triangle ABC is similar to triangle DEF. Okay, now lucky for you, next semester, we are going to do an entire chapter on proving if triangles are similar or not. Okay. But for now, we're just going to focus on the transformation aspect of it. Okay. But we will always have either congruent or similar figures. Okay.
I know that.
plus 10 points. Okay. Guess what? 0 to Colin Cruz during that chapter. All right, let's go to, I don't know, do you have to turn the page? Turn the page. Okay, so a reminder about the composition of transformation is we will apply them in the order that they are given to us. And once we apply it, we use our new shape to do the next one. So for example, first we better plot our coordinates, right? All right, everybody take a moment and plot A, B, C, D. Does it look like yours? Okay. Okay, so the first thing we're gonna do is our translation. Which way are we gonna move these coordinates? To the left, how many? So we're gonna do left 5 and down 3. Okay, go ahead and do that for me. Does your shape look like my blue one up there? Okay. So from the blue shape, we are going to perform the dilation of ×3. Now, a dilation is a lot easier to do if we actually know the coordinates. So we're going to need to think about the coordinates so that we can multiply them by 3, okay? So I'm gonna go ahead and just write down that our A prime is -2, 3. Our B prime is -3, 2. C prime is -1, 0. And D prime is 0, 2. That way it'll just be easier for us to multiply X by 3, multiply Y by 3. All right, so now in pink, where is A prime gonna now be?
-6, 9.
And by A prime, it's gonna go to A double prime, right? All right, from B prime, we're multiplied by 3, and now we're at 6. Okay. C, 3, 0, and then D prime's at 0, 2, so now it's at 3. So I have 3 figures up here. 2 of them are congruent. But the one that is not congruent, we would call similar to the other 2. We have proportional sides, specifically with that scale factor of 3.
For the derivation as well.
So if I offer a space for coordinates, I would want you to write them down, okay? If there's no space to write the coordinates, then I just want the graph, okay? I wrote down the blue coordinates so that it was easier for us to think about that scale factor of 3, okay? All right, so what I would like you to do is, complete number 2 and then stop. Cause I wanna do 3 together. Okay, I'm fine with you working together also.
No.
Okay, it's kind of a checkpoint here. The first transformation is a dilation. I have that up in orange. Check to make sure your dilation is the same. Which means our reflection about the y-axis would look like this. Did you do x-axis?
Yeah.
Oh, good. About the y-axis is the vertical axis. Y-axis here. Okay, so this, the green shape should be your image. Okay, so now what we're gonna do, we're gonna together work on number 3. I just want to talk through the rotation together to make sure that we are still on the same page, okay? So go ahead and plot XYZ for me, please. 9, 6, 3, 3, and 3, 6. It is. Okay, so let's remember our process for rotating. If we're rotating 90 degrees counterclockwise, what quadrant is it going to end up in?
The negative X, Y.
So that's quadrant 2. Okay. Now, our shape is going to the left, which means our paper is going to turn to the right. So take your paper and turn it to the right. And with your new orientation, let's go ahead and rotate. Okay, so now we're going to go right 9, up 6. And we're going to go right 3 and up 3. Right 3 and up 6. So your coordinates should end up at -6, 9, -3, 3, and -6, 3. Do you agree with those?
Yes.
I don't understand.
What don't you understand, bud?
Oh, it's 3, 3. I got it wrong.
Okay. Okay, so now using these coordinates, we need to perform the dilation, which we are multiplying our coordinates by 2/3. So when I multiply -6, 9 by 2/3, what do we get? -4, +6. Do you agree with Sam? Okay. Is this pink shape going to be smaller or bigger than the blue? Okay. 2/3 times -3, 3. Okay. And then -6, 3 times 2/3. Okay. What I'm going to do is I'm going to give you 3 minutes to see if you can come up with on the next page the composition of transformations for each of these groups. So I will tell you for each of them, there are going to be 2 transformations composed together. And I'd like you to figure them out. Ready, set, go. And work together. Yeah. Yeah, right.
Oh.
All right, we're gonna talk about these. I know maybe you're not all the way done with them. Okay, is the image and pre-image in number one, are they congruent figures? No. They're not congruent. Are they the same size? No, which means we have a dilation. Of what? If I take these three coordinates, we would have to multiply them by 1/2 to get the pink coordinates. You disagree?
No.
Okay. But then Sam, what do we do with that smaller triangle? How do we get it to the pink? Okay. We go from XY to what?
X plus 4. Y minus 4.
Y minus what? You say? 4? Question mark? So I don't think it's 4. Let's talk about Y. If we do the dilation of 1/2, then M would go to 2, right? And N would go to 3.
And then 6 would go to 3.
Okay, so then
And then we move it over 4 and then it goes down 1.
only down 1.
Yeah.
Okay.
So
Yep. All right. How about number 2? Dilation of what? It'd be K equals 2. This guy's the first one. What's the next transformation? About? Good. Good. Okay, what about number 3? So we have a 90-degree rotation. Good. Dilation where K equals 1/3. Very good. Yeah.